So 3-7, solving inequalities. First I want to make a comment. If you graph equations that have like, I wouldn't write this, but if you graph something like y equals 3x plus 2, if you graph something with an x and a y, you put it on one of these kind of graphs, right? With like the x and the y axis. What we're going to be doing now is we're going to be graphing inequalities that are all things like this here, x is less than 4, or 2 is less than x, or x is greater than or equal to 5. So because we just have one variable, we don't need a graph like this, we just put it on a number line. Fair enough? Mm-hmm. So all of our graphs this chapter will just be these number lines. You don't have to deal with like x and y values and so on. Okay, then I think I can do that. All right, let's jump ahead then. I guess one final thing is if I take and say, we've been doing things like this. I wouldn't copy this down. I just need a little bit of space. We've been doing things like 2x equals 6. And if you want to find x, what do you do to both sides? Divide by 2, divide by 2. And then when we do that, that 2's drop out, because multiplying by 2 and then dividing by 2, they just undo each other, leaving x equals 3. Does that look familiar? Yep. The new stuff today is going to be taking that same problem, but instead of having a equal sign, they're going to maybe do like a less than sign in there. And just like before, we did our first line, we divided both sides by 2, then we copied that equal sign down, bless you. Now we just copy the less than sign down. So we take what we've been doing the last 3 class days in here, and we do the same thing now, but we'll do it with one of these inequality signs instead. Okay, you have seen the inequalities before, correct?
Yes.
Okay.
No,
okay, so we'll jump to that then too. All right, graphing inequalities on a number line. So we have this problem here. Graph x is, they call this less than 4. So because this, sometimes you'll see people try to explain it, they'll try to draw, I have a blue alligator now here, but if you have like, or a snake, one of those anacondas or something from Everglades, pythons. Do you agree? Pythons, anacondas, they eat big things? So the bigger thing is always going to be on the wider side. I should get rid of my ugly drawing. But so if you have this thing here, the x is less than 4. This is going to be the small side. So x is on the small end of this less than sign. 4 is on the wider part. Fair enough? Yeah. So x is less than 4, or 4 is greater than x. So I'm going to take on my number line. I'm going to put a 4. I put mine kind of in the middle. It doesn't really matter which side you put it on. But if I know my x values are less than 4, is that going to be numbers over here on this side or numbers over here on the right side? Left. So these numbers over here are going to be part of our answer. Could my answer include 4? Is 4 less than 4? No. How about 3.99?
Yes.
Yeah. So 3.99, 3.9999999992 is less than 4. Yeah, I shouldn't have went there. So we want to find a way to say everything right up to the 4, but not the 4. So what they do is they take and they put an open circle here on the 4. So this is trying to say everything but the 4. And now we want to shade. You said that over here like 2 is less than 4. Do you agree 2 would be over here on the left somewhere? Yes. So then we take and we shade to the left side. And when you get to the end, I had a lot of people do this on the test last year. They just kind of left their shading like that. And that's where I marked them off a quarter point. They're still bitter a year later. So when you do your shading, make sure you do kind of like a dark arrow on the end too to show that it keeps going to the left. That was you? So we're saying all the numbers that are less than 4, going down to 0, negative 14 million, 2.5. So all those numbers are over here somewhere, all the way up to 4, but not including 4 itself, because that'd be there. Does that make sense, people? So if we want to graph this next one, x is greater than or equal to 5, we could put a 5 in. Is that 5 going to be part of my answer? Yes, because I could put a 5 in for x, and you agree? We could say 5 is greater than or equal to 5. It's not greater than 5, but it is equal to. So 5 has to be part of the answer. So instead of doing an open circle like before, we do a filled in circle. Who could give me another number that works other than 5? Do you agree 7 is greater than 5? Yep. So one way to figure out where to shade is to say, where's 7 on the number line? Is it over here on the left or over here on the right? 7's going to be over here somewhere. So then we have to shade that side that would have the 7 on it. So we shade to the right. So a comment or two. Sometimes people, they look at these and they say, hey, look, do you agree this is kind of like an arrow pointing to the left? And we shaded left? So the sign points left, we shaded left. Here the sign points right, we shaded right. So that works as long as the variable's on the left side. If instead, here we have x is less than 4, do you not agree another way to say that is though 4 is greater than x, 4 is bigger than x? So now you can't apply that rule because now it's pointing to the right, but you have to shade left. So I think probably the easiest way to figure out which way to shade, and I'm just going to cross out this part here in my notes, is, and maybe I'll say shade direction. You can try to find one of those like little tricks that work, so you could take and change it so the variable's always on the left. I'll get you one sec. But I'm going to say pick a number that fits. So pick a number that fits the inequality. Oops. Fits the inequality. That's what we were doing before up here. We said, okay, 7 is greater than or equal to 5. Comma. Then shade that side. If that's kind of messing with your head a little bit, you could say just pick any number other than that boundary number, the thing you have your circle on. Pick a number, see if it works. If it works, shade that side. If it doesn't work, then shade the other side. So we did an open circle here when it was less than. So after open circle, I'm going to put a less than sign. What's the other one that will give us an open circle? Less than or not the equal to, because the equal to gave us the filled in circle here. Yep, so more than, or I'm going to say greater than, so less than or greater than. So open circle will be when you have one of those. If they have the line underneath it, this sign here is kind of like a hybrid of, or a mix of the greater than or part of an equal sign. So closed circle, you fill in the circle and you have a less than or equal to, or a greater than or equal to. Because the line underneath is just part of an equals, it's saying or equal to. All right, let's hit this sucker. So 2 is less than x. So I'm going to put my boundary line on the number 2. Open circle or filled in circle? Open. And now, what's a number that I could put in here for x? 0 or 5 or something else. So if we put a -5 here, is 2 less than -5?
No.
No, 2 is not less. So that -5 wouldn't work, but we could say 10. Do you agree 2 is less than 10?
Yes.
Okay. Then you say, well, is 10 over here on the left or over here on the right? Right. So we need to shade the side that would have our 10. You don't have to write in a 10, but 10's over there somewhere. So shade that side. Make sure you put your arrow on the end. So next year in algebra class, you're not like, all right, this teacher in 8th grade, he was the biggest jerk ever. He marked me down a quarter point for not putting an arrow on the end. So, but put an arrow on the end. Good?
What if the arrow's already there?
Then you still have to make your arrow on it. So yeah, don't just rely on a little arrow like that. Make a bigger one. So I'm picky at least. I don't know about your teacher next year. This next thing here is, I kind of hit at the beginning. It's just a combination of what were you doing in the last 3 sections and the new stuff. So I want to take this inequality, x plus 4 is less than or equal to 27, and I want to just make it x is less than or equal to something. So what do I do to get x by itself? Yep, they added 4, so we subtract 4. Subtracting 4 is the inverse of adding 4. Then we do that. 27 minus 4 is 23. And then you just copy down that less than or equal to sign just like we did when it was an equals. So now my boundary, my end point is going to be a 23. If it's x is less than or equal to 23, do I do an open circle or filled in? Closed, yep. Because 23 could be part of my answer, right? What's another number that would work for x? X could be, we had you last time. Somebody else, throw out a number. 9.2. There's always one. Okay, 9.2 is less than or equal to 23, agreed? 9.2 on the left or on the right? Left. So 9.2 is going to be down here somewhere. So we shade to the left. And we put our little arrow on the end. And we're good. One more. Any questions before we do the last one?
No.
All right. Then, first step, divide by 4 or subtract 17?
Minus 17.
Yep, we always do our addition subtraction first.
No.
And when I do that, I get a 4x by itself on the left. Copy the sign is greater than negative 8. Because 9 minus 17 gets us down in the negatives. And between the 4 and the x, we have a multiplication. So x was multiplied by 4. That means we divide by 4. If you do it to the left, you have to do it to the right. And I get a x is greater than negative 2. So negative 2 is our endpoint, so I'm going to put that in there. Open or closed?
Open.
Open. Now, which way do we shade?
To the left. Wait, right.
Yep. Because a number that would fit, you could say, well, maybe 4 is greater than negative 2. So if positives like 4 are going to be over here, so we shade to the right.
0.1.
And you don't have to put on the 4. That's all I have.